on the left or right side of the subtraction sign. The one on the left side is called minuend. The one on the right side is called subtrahend. Now the reason why they give them different names is because you can't reverse them. They're not interchangeable. With subtraction, you can't commute things. So an example of minuend minus subtrahend equals difference is this. 9 subtract 3 is equal to 6. Now there are quite a few words that go along with subtraction, but unfortunately because of the way English has a habit of saying different things in different ways and one thing in many different ways and so forth, some of the words don't mean exactly the same thing in terms of the order of minuend and subtrahend. We'll get to that in just a few minutes. If we were dealing with addition, the two things that are added are called addends. They're both called addends. And it doesn't matter which is left and which is right of the addition sign. So in other words, addition is commutative, subtraction is not. So if we try to switch these around, we would get the same answer. That's not 6. It turns out to be a negative number, and that's what we're going to be looking at today. We'll actually develop the ability to understand what that negative number is. So what we're going to do now is go back to the real line. Remember, if we were doing addition, let's do that in blue. Something simple like, let's say, 3 plus 2 equals 5. The picture looks like this. We're going to start at 3, put a dot there as our starting point. Plus means we're increasing. Increasing for the real line is always to the right. How much? By 2. And there you are, 5. So it's a hopscotch kind of thing. You go to the right when you're doing addition on the real line. And it doesn't matter where you are. You could be back here to the left of 0. Still, you do that. So if you started out with, let's say, minus 6, and you wanted to add 2 to it, same thing, you'd be at minus 4. So addition has that particular visual way of looking at it. Now the question is this: what do we do with subtraction? If we want to do a very simple subtraction problem, let's say we want to do 6 minus 4. Well, we memorize subtraction tables, so we know what the answer is right off the bat. It's going to be 2. But if we tried to draw it up here, let's see what we would come to. Of course, we start at 6. But now, because we're subtracting, most of us have the concept that subtraction means decrease. So we want to decrease that number 6 by some amount, and the particular amount, of course, is 2. 4 rather, in this case. So we want to decrease it. Decreasing numbers on the real number line go to the left. So we'd have to decrease it by 4. Here it goes. 1, 2, 3, 4. So we come up with 2. Okay, but notice what we just did is exactly what we would do if we were doing an addition problem with a negative number. In other words, suppose I change this to this. Suppose I added to 6 the number minus 4. Well, yesterday we found out to add a negative number, you have to go backwards. You have to go in that left direction. You can't go in the front direction or that way, because that increases. So the only way to add a negative is to go backwards. But that's just exactly what we did to subtract. Which means that these two things are the same thing. This is also 2. So from now on, the definition of subtraction goes like this. The amount A minus B will be done by changing addition to subtraction of the opposite. Okay, let's see what this means. 6 minus 4 equals 2. All right? Sorry, we don't do subtraction anymore. Imagine that. You're never going to do subtraction again in this class or any other math class you have. What's the subtraction key on the computer for, the calculator? Useless now. No, I'm kidding. You can still do subtraction. All right. We changed addition, excuse me, subtraction to addition. But we want the opposite. That number is 4. The opposite of 4, we say, is minus 4. Now we go back to the two rules. And the true rules from yesterday are, if you've got opposite numbers, you subtract smaller absolute value from larger and attach the sign to one with the larger. Okay? So we're going to change subtraction to addition to the opposite. Now that takes 10 seconds to get used to. Strangely enough, it comes very quickly. You have to do it for problems and see what happens. Suppose we started out with a minus 7, subtract 12. Well, if we were doing that, before we talked about this change here, we'd probably get several different answers in class. But what does that mean to us now? The minus 7 is a negative 7. That minus sign stands for a negative number. That's the opposite of 7. But that subtraction sign now gets changed to addition. And we have to take the opposite of 12. Well, the opposite of 12 is a negative 12. So you need parentheses. Now you're in case 1 for addition, same signs. So you add the two absolute values and attach the common sign. So that's going to be 7 plus 12 is 19 minus 19. And we probably would have gotten some different opinions on that before this agreement here. Okay, let's do something like this. 40 subtract a minus 8. Okay. As far as we're concerned, that's going to be 40. Add the opposite of minus 8, which is a positive 8. That answer is 48. So one of the reasons why this thing comes up of changing subtraction to addition of the opposite is these things with lots of minus signs in them. Because most people get quite confused by that. And most people, therefore, don't get a right answer to that. So we have to do something to get it back to the possibility, increasing the possibility of getting the right answer. So we'll try a minus 3, subtract a minus 5. Now that's the one where we get all sorts of answers, right? Too many minus signs, the mind turns into jello, No, but not for us, because we say, sorry, I don't do that. I do minus 3, add the opposite of minus 5. The opposite of minus 5 is a plus 5. Okay, now I've got opposite signs. I'm doing addition now. I've memorized the two rules for addition. So that's case 2, opposite signs. Subtract smaller absolute value from larger to give you a 2, and attach the sign of the one with the larger absolute value. That will be positive, and that doesn't get us. Okay? Suppose we have minus 11, subtract a minus 2. For us, it's going to be a minus 11 plus a plus 2. Subtract smaller absolute value from larger, 9. Attach the sign of the one with the larger absolute value, minus. That's a minus 9. So those two rules from yesterday are the key to the whole thing. You just have to have them in your back pocket. It's the kind of thing to memorize. And that gets us past all the problems with subtraction, except English. Doesn't get us past that. All right, so let's take a look at our English to math translation table again. Luckily, they reprinted it for us on page 603. And they give you a word or phrase that's used in English. They give you an example of how it could be expressed with numbers. And then they show you the actual maps. And pretty much everything on that table is okay, except the last two entries. A minus B, well, yeah, the order of the A and the order of the B it remains exactly the same. For example, minus 15, minus 10. That minus does mean subtract, so it goes like this. Minus 15, subtract 10. It just simply keeps the order in English. 15 minus 10 is 15, put a minus sign in, 10. 15 on the left, 15 on the left. 10 on the right, 10 on the right. Okay. The next two also do keep that order, but this does not. A less than B. The example might be minus 12 less than 5. Okay. There's no way to get around this because it's a problem with the language itself. The mathematics of what we do is clear. Mathematics is a very precise process. But English is not clear. All right, minus 12 less than 5 means you have to reverse the order. You start out with 5 and reduce that 5 by a minus 12. So minus 12 was on the left, now it's on the right. 5 was on the right, now it's on the left. And how do you reason about that? Well, you can say something like this. A less than B implies that I'm reducing B by a certain amount, which means I'm taking something away from it. And if you can remember that much, then you can write this down correctly. I've got to start with the 5 and take something away from it. So that's why this thing now becomes the left side of the minus sign, where before it was on the right side of the phrase. That's the way it is. And it's also true with this one. Subtract A from B. An example would be subtract minus 3 from 8. Again, reverse the numbers. That's 8 minus a minus 3. You have to reduce 8 by a minus 3. Okay. Let's do some problems here. We'll take the English and get the expression and get the right answer for it. I know it seems ridiculous to keep going back to English and reminding ourselves of all these little problems, but see, the way you get paid for mathematics is someone comes up to you and gives you a problem to solve, but they give it to you in English. And so you have to translate the English into the math correctly and then use the right math. You know, so there's extra added layer of stuff you have to do. It's just the way the world works. All right, 12 less than minus 8. All right, we've got to be able to get that sentence right in math. Okay, it's one of the problem ones. These two right here, the problem ones in that table. All right, so that means I'm going to take something away from minus 8. How much? 12. Okay, now that's getting to the correct math. And the next step is to go to the answer. And the answer is, I don't do subtraction. I do addition of the opposite. So it's going to look like this. Minus 8 plus, the opposite of 12 is a negative 12. Now I'm back into addition. Rule 1, because it's the same signs. Add the two absolute values to get 20 and put a minus sign in front of it. All of that to get the correct answer to that. Yeah. I think I told you the story about my student who was working down in Merrill Lynch in the barnyard. He said, I got this job because I took those classes. He said, they tested me for this job. He was sitting there, he was a receptionist for Merrill Lynch. But as a receptionist, he had plenty of spare time, so they used to give him a lot of mathematical things to do, you know. And they gave him tests on how he did with numbers and stuff like that. Got to be able to do it. All right, let's throw in some decimals and fractions. They don't change anything. Everything we've talked about is the same for all of that. minus 6.7, subtract 4.2. Now let's say you're on a desert island going to your soccer ball and you don't have your calculator. What happens?
Go swimming.
Okay, you go swimming, right, of course. So, why didn't I think of that? All right, so we change the subtraction to the addition of the opposite. In other words, same thing happens with decimal numbers as it does with regular whole numbers. No difference at all. All right, same signs, add the two absolute values, 6.7 and 4.2. 10.9, attach the common sign. There it is. Huh? You could do this on the calculator. It would look like this. Now, this depends on your calculator, whether you insert the change sign key before the number or after the number depends on the brand of your calculator. I think that question came up yesterday. I just want to emphasize that. I think Texas Instrument always wants it first, but some of the others don't. So you just play with your calculator to find out. I'm going to do it second. This would be a 6.7 entered in on the keypad. Then you have to put a change sign button. Okay, it could be anything. It could be, let's do the plus minus one. Now you've got a 6. At this point, when you push that button, you'll notice on the readout, it does put a minus sign in front of the 6.7. And then you say, okay, I want to add to that. So you push plus, and then push in 4.2, and change sign button again. And then equals. Equals says I'm done. And if you have your calculator, you can try it out. You should be getting minus 10.9. Let's do some fractions. 3/10 subtract a minus 7/30. And now we've got several things we have to be careful with. One is the subtraction problem, and the other is the LCD problem. And you say, well, which should I do first, which should I do second? Actually, it doesn't matter. You can do either one first or second.
LCD first?
That's fine, we'll do the LCD first.
Do you have to reduce? Can you reduce first?
We're not reducing, we're going to switch to the LCD. Okay. So the LCD for 10 and 30 would be the smallest number that both 10 and 30 divide into to give you an even result. In other words, no remainder. 30. Okay, this one is in 30ths, so we don't have to do anything there, but we do have to convert this one. So we multiply the bottom by 3, which means we multiply the top by 3. Standard LCD conversion. It becomes 9/30ths, and this is minus a minus 7/30. Okay, so now we're back to denominators that are the same. But still we have to do something with the subtraction. We don't do subtraction, we do 9/30ths plus, and the opposite of 7/30ths, negative 7/30ths, will be a positive 7/30ths. And now we simply add the numerators, 9 plus 7, put it over the common denominator, so that gives you 16/30ths, and that reduces to 8/15ths. So there's the correct answer. So there's sort of a step-by-step kind of process, and you have to do the steps in the right order and get them right. Okay, let's do some more. Once in a while you have a string of numbers that have to be added or subtracted, so let's see how that would go. Minus 4, subtract 6, add a minus 3, subtract 5, add 8. Again, this could be done with the calculator using the change sign button. All right, but let's say we had to do it, we didn't have our calculator. Actually, the first thing to do here is change all the subtraction to addition of the opposite. That's the easiest way to handle it. Okay, so this is not subtraction because there's nothing over here. So this is a negative number. So you leave that alone, that's fine. But this becomes plus, and the opposite of 6 is a negative 6, huh? Okay? Now this is a plus already, so there's nothing to do there. This becomes plus, and that becomes a negative 5. And this is already a plus. Now notice 1, 2, 3, 4 negatives, huh? Right in a row. Yes?
On the negative 3, does that change the positive?
No, this negative 3, see, we're not changing here because we already have addition.
Oh,
So we just leave it as addition of that number.
okay.
The only thing we're changing is the subtractions. The subtractions get changed to addition. So we end up with nothing but addition. Okay, well, when we're adding negative numbers, we simply add all the absolute values and attach the common sign. So you could add all of them at once if you wanted to. 4 plus 6 is 10, plus 3 is 13, plus 5 is 18, and the common sign is negative. So we're done with the negatives. But we still have to add that positive. Now, there's no way to wiggle out there. We actually have to use a rule 2 for addition. Subtract smaller absolute value from larger to give you a 10, but attach the sign along with the larger, so it gives minus. Now, if you used your calculator to, change the sign on that, subtract 6, and so forth, go all the way across with the buttons, calculator, you should end up with negative 10. And you can try, if you don't have it now, you can do it later. So all I'm saying is just be careful that you do understand your change sign button, when to use it, before or after the number, because on the next test, of course, you'll have problems like this. You want to have your machine be ready so you can do it. All right, let's take a look at another. This is a PEMDAS kind of thing. Okay. 3 subtract a negative 4, but that whole thing wants to be raised to the second power, which means it wants to be multiplied by itself. Okay. According to PEMDAS, which, just in case you might have remembered, might have forgotten. Okay. What does it say? Do parentheses first, huh? All right, now technically the only parentheses is this minus 4. But that's done for clarity. That's done just to be sure that you understand you're subtracting a negative 4. So that doesn't really count here. But this, remember, always includes not only parentheses, but any grouping symbol at all, like square brackets or curly braces. They're all included in this one category. So next we have to go to this, which means we're forced to do that next. Forget the exponent, it's lower on the totem pole. We're going to do what's in those square brackets now, huh? And we don't do that. We do this. We do 3 plus 4. Because we're changing to addition of the opposite, huh? And 3 plus 4 is 7. And now we finally square, so you get 49. Huh? On page 605, down at the bottom there, they even give you a pretty picture. There's a helicopter up above the ocean, and below the ocean, a submarine. The helicopter is hovering at a height of 200 feet above the ocean.
What page did you say?
605. A submarine is directly below the helicopter, 125 feet below sea level. Find the difference in elevation between the helicopter and the submarine. Now, first of all, it's important to understand where the 0 is in this picture. Huh? You got the blue for the ocean and the white above for the air. The 0 is right at sea level. Okay? Now that's pretty standard when you're talking about oceanic kind of things. If you go into the ocean, it's considered negative, and if you go above the ocean, of course, it's considered positive. Now they want to know how far away these two things are from each other. So what we're going to do is take the height of the helicopter and subtract from that the depth of the submarine. but we have to be careful how we do it. The height of the helicopter is a plus 200, 200 feet above sea level. But the depth of the submarine is a minus 125, because you're down below the zero. And therefore, sorry, I don't do that, I do this. I change subtraction to addition, and I gotta take the opposite of that, which is 125, and so finally it's 325. That's the actual distance between them, huh? Let's do some more PEMDAS ones. Okay, we've got several operations there. We have parentheses, we have exponents, we have subtraction, we have addition. So PEMDAS is what we have to do next. And it says do your parentheses first. All right, so we want to go in there. Minus 1 plus 11. Well, that's, again, rule number 2. Subtract smaller absolute value from larger. Attach the sign of 1 with the larger, that's 10 squared. We still have to do the squaring. Now down here, we change to addition of the opposite, and the opposite of a minus 2 is a plus 2. So this becomes 100, 10 squared, divided by 12. And then you can go ahead and divide it out as a mixed number, or you can certainly reduce it. 4 would go into both of those. That gives you 3, that gives you 25. So you could write this as 25 thirds, or if you love mixed numbers, just go ahead and divide it. You'll have a homework problem, something like this one. This has to do with temperature ranges. So let's talk about range and what range means. The book does tell you there. They have a set of temperatures for 1 week in Fargo, North Dakota. Looks like this. 6 degrees, minus 6 rather, minus 2, minus 10, minus 4, minus 12, minus 1, minus 3. Not a place we'd like to be so much, but it is. Those are the degrees. Okay, and they want the temperature range. Okay, so let's write down what range means. Range means highest minus lowest. It's kind of similar to the helicopter submarine thing, but the highest, well, the highest would be the most, to the highest meaning over here on the number line, it'd be the one that's furthest to the right. Well, the one furthest to the right there is minus 1. It's right there. That's a balmy day in Fargo, North Dakota. Minus 1, okay? The lowest is minus 10. So it's going to look like this. Minus 1, subtract the minus 10. And again, change to addition. Opposite 10. So there's a range of 1 from 10 is 9 degrees. That's a 9-degree range for that particular week. Okay? Has anyone been in temperatures like that? Negative temperatures? Not a fun thing to do.
I found out a trick to it.
What you did?
You freeze and you just stay there.
Oh.
I mean, it's like you can't do nothing.
So you sit by the fire, is that the idea?
No, actually, I've had guard duty at one time.
Oh.
And it was so cold that I froze with my weapon like this.
Yeah.
And all I could do is move my tongue.
He's like, freeze! They're literally freezing.
Yeah, I mean,
Well, I mean, obviously he survived, so. Wow. I didn't even like to hear stories like that. All right. That's not my thing. Okay. I'm going to give you a couple homework problems in the calculator connection section, because I want you to get used to your change sign key. I know we did some yesterday, but let's do some more. Because you'll need this on Friday. Not this Friday, but a week from tomorrow. And tomorrow we will have a lab.
Go ahead.
So play with this different definition of subtraction. It'll come very quickly.
No problem.
wow, that's a lot.
Just keep going.